Video is going to give you the solution to the second part of the defaulting customer assignment. So if you've not done so already, make sure that you've done the univariate descriptives class exercises. So you're going to go down to question 2, and then there were 2 videos. So one is a short one that shows you how to read in the data. There's another video that shows you the solution to the remaining parts. It's very important that you've done all those things, because what all those parts do is lead you to a data set. Let's go find the thing. So this data set has all the labels in it and has a couple variables that you computed, age 2, log down, and month, in doing that previous exercise. So it's really a continuation of that, and if you haven't done this, what I talk about in part 2 doesn't really make that much sense. So we have to go about 5 pages down, and here we go. So we're going to focus on the multivariate descriptive statistics class exercises, and we're going to go down to the defaulting customer. I think that's problem 2. Here we go. So this continues to use that defaulting a customer thing. Now, the gender variable gives the gender of a member, where 1 is male and 2 is female. Let's go see if I've done that already. I think I've already assigned male and female. Turns out I haven't. So we need to assign those value labels. So I need to assign value labels so that male and female show up in the output rather than 1 or 2. Are males or females more likely to default? Submit a crosstab in support of your answer and indicate which is more likely to default. All right, so let's do all those things. Gender, to get those labels in, we click on the values right here, and then those little dots. And what was it? 1 is male, 2 is female. So 1 is male, 2 is female. Go hit OK. We click on data, now they pop in. We need a crosstab. So analyze descriptives and then crosstabs. I will put gender in the rows, and we'll put default in the columns. At this point, go check on cells, and since I put gender in the rows and I want a condition on gender, so I want to know what percentage of males default, what percentage of females, I want row percents. Go hit continue and go hit OK. And so what you'll see is that 13% of men default, 10.4% of women default. It looks like the men default at a slightly higher rate than women. All right, rather than, well, let's see, I need to find this in my course packet. And then we'll just walk through this. So the next part says, answer the previous question using compare means instead of crosstabs. So let's do that. Sometimes it's easier to use compare means, sometimes it's easier to use crosstabs. So analyze compare means, and then we're going to use means. Default is the dependent variable, and then gender is going to be the independent variable. So it's like we're going to condition on gender to understand the percentage who default. And what you'll see is you get exactly the same answer. So 0.13 is the mean of male. Remember, the mean of a 0-1 variable is the percentage of 1, so 13% of males default, 10% of females default. Part C, find and interpret the correlation between gender and age. Disregard this. We're not doing correlations in this course this year, so forget it. Move on to part D. Well, I'll show you, although you're not responsible for it, because it's kind of good to know this. Analyze, correlate, bivariate, and we're going to bring gender and default in, and then we'll go hit OK. The correlation is slightly negative, and what that means is larger values of gender are associated with smaller values of default. So remember, 1 was male, 2 was female, therefore as female, as you go from male to female, the default rate decreases. Part E. Continuing the previous part, you will implement a bin smoother, which is also known as a regressogram, which is an idea extending a histogram, to study how age affects the default rate. Well, let's go look at age. The problem we have with age is that it has a whole lot of unique values. And so if we just did what we just did with gender, that is, compute the default rate for each age value, you're going to see a very jagged relationship. I suppose we could do that. We could visualize this with a bar chart, say. And if we do a simple bar chart, actually, I think I will do gender first, just to show you that you get exactly the same story. We're going to stick the mean of default is what the bars represent, and we'll stick gender on the category axis. And so you'll see that you get a bar chart that shows what you got with compare means or with the crosstab. 13% of males go away. Well, let's just go exchange gender for age in that box. So we're going to get gender out, and I'll stick age in. And the problem we're going to have is that it's going to be very jagged. So it's jagged because the sample sizes are quite small. So if you think about what we did with a histogram of age, we had to form some bins first, and then we counted people in the bins. So a histogram would show the percentage of people in each age group as the area of a bar. Okay, we're going to do something slightly different. You can think of this as an extension of a histogram, where instead of the percentage of people with each age group, we're going to show the percentage of some other variable, in this case defaulting, for each age value. So I've given you a real clever formula, I think. What this formula is going to do is put people into age groups like 25 to 34, 35 to 34, so 10-year chunks. I'm going to reset this. I'll make a new variable called age bin. And let's just type in the expression I gave you. So 10 times RND age 2 over 10. I've gotten a lot of questions about age 2. You created age 2 in the previous assignment, where we cleaned out the values like zeros and 99s. So that's why it's really important for you to start with the data set that you created last time around. So let's go look at the data. And so what you'll see is that age bin for people, let's go find age here. People ages 28, they're in age bin 30, if you will. So that 30 really represents 25 to 34. Okay, a person who's 22 gets mapped into the 20-year age bin. All these 28 go to the 31, the 29 goes to 30, and so forth. If you want to study this in a very systematic way, we could do this with compare means. So let's go up to Analyze, Compare Means, Means. We had default and gender in there before. Let's reset this, and we'll study the relationship between age bin and age without outliers. Now go into Options, and let's get the min and the max in. We don't really need the standard deviation, don't really need the mean even, so we'll get those two out. And what you'll see is that age bin 20 corresponds to 16 through 24, age bin 30 is 25 through 34, 40 is 35 through 44. So this is just a clever way to group these age values. So we're now in a position where I could go generate one of these bar charts. Why don't we do a bar chart? So graph, analyze, bar chart, and we'll define it. We'll get age out, get age bin in. Go hit OK. And so now you don't see this jagged thing. I mean, the story of the jagged thing was, it looks like as you get older, you're less likely to default. You know, these people in their early 20s are the most likely to default. Well, you still see that story. As you get older, you are less likely to default, but you don't see all the jags. So because we've aggregated the data, we have more observations in each bar, and that's why it's not so noisy. I suspect this 80 bar is noisy, so there aren't a lot of 75 to 84-year-olds, and so this is kind of a noisy estimate. All right, part F. This part illustrates another application of compare means. Which ages are assigned to each level of age bin? Well, I guess we already did part F, so that was the answer to part F right there. Part G. Generate and submit a bar chart plotting mean default status against the age variable. Well, we just did that too, so that's part G. Part H. How does month, the month during which a customer joins, affect the likelihood of canceling? Support your answer with appropriate descriptive statistics or graphs. Which months, if any, have higher default rates? Well, I like the graphs. So we made that month variable. Actually, I better go show you that. We made that month variable in one of the last parts of the previous exercise. So you've got to, again, you've got to do that previous exercise before you do this one. So at this point, it's quite easy to study the relationship. We'll get age bin out, get month in, go hit OK. And what you'll see is it's moderately flat. Okay, people who join in January, February, or March have about a 10 or 9, 8% chance of defaulting. Those who join the rest of the year are a little bit higher. Then those who join in November or December are a bit lower again. So it looks like those who join in winter tend to stay around a bit longer. Those who join the rest of the year are a little bit more likely to default. The magnitude of the differences, I would say, are comparable to men versus women. So summer versus winter is sort of like men versus women. Part I, form quartiles of both down payment and use. So we're going to go into, let's see, transform rank cases, and we're going to bring both down payment and use in. Now, if you click on rank types, what you'll see is that the default is to give you ranks. So it's going to number these from 1 to 25,000. You don't want that. So click on N tiles and uncheck ranks. Now, N tiles by default gives you 4, which will be quartiles. So this is an alternative way to form bins. In the age example, we put them into 10-year chunks. Here we're going to put them into 4 groups of roughly equal size. So if we go back to our data set, you will now see 2 new variables. Here are the quartiles of down payment, the quartiles of use. Probably a good idea to save this data set. So I'm going to go hit Command S, and you're going to see the little disk light up here. All right, so we just did that, and I give you a bunch of hints. Make sure that N tiles is set to 4. I think we've done all this. Let's go on to part J. So part J reads, run a frequency distribution of N use. Let's go do that. I suspect we're going to have to run a frequency distribution of down payment too. So let's get month out. Let's just bring both these variables in. You can do a shift click to bring multiple variables in if you want. Go hit OK. So if you look at use is down here. It only takes 3 values. Why is that? Well, the problem that we had, this was an exercise from the previous problem. Let's go back to use. I still have that run that we did. And here's use. You're going to see that 39% of, almost 40% of people have a use of 0. Now if we're going to put these into quartiles, that creates a problem because way over a quarter of our data is 0. So it's not like you can put some of the zeros in the bottom quartile and some of the zeros in the next quartile. So what SPSS is going to choose to do is assign all those zeros. Here you see that 39% to the 1, quartile 1. Then it's going to try to divide the others up evenly. If you don't believe me, you could run a crosstab. So let's go do descriptives crosstabs, and let's reset everything. We'll put use in as the rows, I guess, and the percentiles in as the columns. And sure enough, it sticks all those zeros into that into the first quartile. So 40% of your data fit into that quartile. It skips quartile 2 and then assigns the others accordingly. All right, does payment type affect the likelihood of defaulting? Support your answer with appropriate statistics or graphs. Well, let's go into graphs. I like these bar charts, and we'll hit define. Let's get month out, and we're going to bring down the payment type I think we're asked about here in part K. How does the payment type? Cool. Bring that in. Go hit OK. And so what you'll see is that people paying with book or statement are much more likely to default than those with either of the EFT methods. How does the quartile of down payment affect the likelihood of defaulting? Well, again, one comment on part K before we move on. Notice the magnitude of the differences. So with age and gender, we had differences of 10 to 13%, so from 10% to 13%, or 10% to 14 or 15% in the case of age. Here we're going from 25, almost 25, down to almost nothing. So we would say that payment type is a much more important variable than in explaining default rates than age or gender. Part L asks about the down payment amount. So we'll go to Legacy Dialogues, bar chart, simple again. I'm going to get payment type out, and let's put the down payment quartile in. So we have these 4 chunks, and the story is the more money that you put down, the less likely you are to go away. And the magnitude of these differences is similar to payment type. So with a very small down payment, there's almost a 25% chance that someone goes away. With a very large down payment, the person almost never goes away. Part M. How does the quartile of usage affect the likelihood of defaulting? Support your answer with reasonable graphs. Okay, well, let's just keep doing our bar charts, I guess. Or, yeah, you might want to try lines also. And the answer is the more you're using the club, the less likely you are to go away. The magnitude of the differences between those who aren't using the club and those who are is comparable to payment type and down payment. Generate the following line plot and turn it in. So I think we're going to use down payment, use, and payment type. So I'm going to go generate that line plot. Let's go into graphs. I'll generate one just like what we have, what I described. We're going to put the default variable representing the lines. I'm going to put down payment as the category. Let's use the payment type into the lines by box. And then we're going to panel by the percentile of use. So we'll put use down in columns, payment type, define lines by, end down payment in category, and then other statistic, default, mean of default as the lines represent. This creates a pretty sophisticated graph. So what you'll see in this graph is different colored lines for each of the different payment types. Blue is book, green is statement, then the 2 EFT methods. You have the amount that you put down on the horizontal axis, and you have the percentile of use. So these are people who aren't using the club. These are people using it a little bit. These are people using it a lot. The way to interpret this graph is 3 strikes and you're out. So if you've got 3 possible strikes against you, you could have one of these payment types that are not very good. You could not be using the club, and you could put a small amount down. Now, if you have any combination of 2 of these, you're okay. So let's say that you are using the club a lot. However, you put very little down and you pay with one of these bad methods. Well, you'll see that the default rate really isn't that high. Likewise, let's say you pay with one of these bad methods and you are not using the club, but you put a lot of money down. Well, you're not likely to go away. Okay, so you can have 2 strikes against you and it's not a disaster. However, if you have all 3 of those things against you, so let's see, here's book. They are not using the club, so that's this box, and they don't put much money down, then there's about a 67% chance that they go away. So this is a very it's a very multivariate graph where we're showing 4 variables at once, how default status depends on 3 other variables, and I would say it's a pretty sophisticated graph for that reason, and that it's studying 4 variables simultaneously. Part O, memberships are for 3 years. What relationship do you expect between price, down payment, and monthly dues? Does this relationship hold approximately? So, if it's a 3-year membership, this is what I would expect. So, the price of the membership should equal the down payment plus I'm going to pay 36 sets of monthly dues. Now, I mentioned approximately. I suspect that Bally would probably give you a price break if you put all your money down at first. It seems like they should as an incentive, because for one thing, they have that money on day 1, and there's no uncertainty associated with it. If I have to wait for the money to come in for 3 years, there's a lot of uncertainty. A lot of people go away. Plus, Bally doesn't have that money, and therefore can't collect interest on it. So there ought to be some discounting there. But price ought to equal roughly down payment plus 36 times monthly dues. So I'm going to go into transform compute, and I'm going to make a variable called diff. Let's reset everything. Diff, I'm going to say, is equal to the price minus the down payment minus 36 times the monthly dues. So this thing ought to roughly equal 0. And we can check that by going into Analyze, Descriptives, Explore. So let's reset this, and I'm going to bring diff in and hit OK. One more thing, let's get some percentiles. Go hit OK. And let's start with a box plot. All right, you'll see this box plot is centered near 0, so there are a lot of cases where it is fairly close to 0, I guess. But there's a lot of instances where you're just way off. So looking at the percentiles, the median, you're almost $600 off. Sometimes you're as much as $1,200 off, actually probably more than that if you look at the max and the min up here. So almost $5,000 off one way, $4,000 off the other way. So I think there's something very wrong with some of these variables. Probably price or the monthly dues look amazingly low. I don't quite know what's going on with that. So I don't trust that variable. And that's it for this video.